Dear students, welcome to today's class. Today I am going to explain a very important chapter which is the backbone for the remaining chapters of the mathematics. The chapter name is set theory. So this chapter is a very important for your state board examinations and CBSE examinations and your JEE mains, NDA, all types of examinations. The chapter is a very important. After this chapter only you will come across relations, next functions. So remaining all chapters will follow from this chapter. Okay, now what is this set theory? Let us start our class. In this class I will start this is object, next is what is a set, next I will explain what is a well defined and not well defined. Some notations I will explain. So representation of a set in roster form or list form and set builder form. Okay, so first let us explain one by one. Okay, so let's start our class. Welcome back. So in our mathematical language, what is an object? In mathematical language, so in general language, object means different definitions will come. But in our mathematical language, object means anything which is living or non-living. What is living? Anything living. So for example, name of the persons, Ramu, Gopi, yes, they are called objects. Non-living, pen, pencil, anything, pen, pencil, rose flower, rose, jasmine, rivers, Ganga, Yamuna, Krishna, all these things comes under objects. Understand? All living or non-living, all these things comes under object. Understand? Okay, now. So after learning this, what is meant by object, so let us start the definition of set. What is a set? So first of all, this set theory was created by a great mathematician. His name is George Cantor. So he is a great mathematician, George Cantor. He belongs to Germany. Okay. So when he introduced this set concept, so everybody thought that it is not the concept, which is not the chapter which belongs to mathematics. They everything thought that this is a chapter belongs to some philosophy, psychology, like that. But afterwards, everybody came to know the very importance of this set theory. After this set theory and the relations were developed, after relations, functions developed after functions. So everything is connected in and around functions. All calculus, geometry, everything is connected with the functions. Okay, now. So he is the main George Cantor was a main backbone of this chapter, set theory. So now what is a set? So what is a set? A collection of well-defined objects. A collection of well-defined objects. Here there are three things we have to observe. What is that? Collection, well-defined, object. Already object. What is object? I already explained. So what is it object? It is a living or non-living thing. Anything. So if you collected, that collection should be well-defined. This is the word well-defined. What is well-defined and what is not well-defined? For example, if I have taken a collection of some objects, for example, if I taken a collection of some objects, what are that object collection? I have taken like this collection. What is that? Pen, pencil, math book, rose flower or jasmine flower, bench, chair, hammer, anything. So these are all so on. These are all collection, one collection. Pen, pencil, math book, rose, bench, chair, hammer. This is a collection. So when you say that, you say that an object belongs to this collection or not. Can you say, for example, if I say that here so many objects are taken. If I take duster. So if you observe, all these things are belongs to some one school property like that. So pen, pencil, math books, rose, bench, chair, hammer, all these things. So if you take any object, we can say whether that object will belongs to the collection or not. You should be specifically say. For example, if I say duster, I don't know whether the duster belongs to this collection or not. I cannot define clearly. Understand? If I say that collection of 5 good books, collection of 5 good books, right? Here the word good is there, no? Collection of 5 good books, no? It is not well defined. It is not well defined. It is not well defined. Why it is not well defined? Not well defined. Why it is not well defined? Why? Because the word good may differ from person to person. Whatever the good, what you think may not be a good for others. So if I ask our students, sir, go to library and you bring some 5 good books, means definitely no 2 students will bring the same books. Why? Because if the person A brings some 5 good books, if it is a cricket player, he will search all the books which belongs to cricket, and he will bring the biography of Sachin Tendulkar, he will bring the biography of Major Dhyan Chand, like that, cricket players, and sports persons books he will bring. If a person is very interested in movies, pictures, like that, he will bring the autobiography of Amitabh Bachchan, like that, all those books. But this word good means it differ from person to person. That's why a collection of 5 good books, it cannot be called it as a set. Understand? Right. If I say that collection of first 5 natural numbers, collection of first 5 natural numbers, right? Anybody can say, what are the first 5 natural numbers? What are the first 5 natural numbers? 1, 2, 3, 4, 5, 6. Anybody can. So if you ask anybody, they will say that the collection of 5 natural numbers will be 1, 2, 3, 4, 5, 6 only. If you go any country or anywhere, anything, the collection does not define. So if I say that, for example, 7, the number 7, can it belongs to that collection? No, everybody can say, no, it does not belongs to. The number 6, is it belongs to first 5 natural numbers, means 1, 2, 3, 4, 5. The number 6, is it belongs to that collection? No. The number 3, is it belongs to that collection? Yes. Is it number 1 belongs to this collection? Yes. That means this collection is well defined. That means in a collection, if given an object, you should be in a position to, any object, if it is given one object, you should be in a position to tell whether that object belongs to that collection or not. Understand? You should be specifically. If I say that if one book is there, any book, I cannot say that book belongs to this collection or not. Why? Because that book, whichever may be good for me, that may not be good for others. Understand this? Okay. So this is a collection of well-defined objects is called a set. Very, very important. Understand? So collection means what? Any set of, any group of objects. So maybe living or non-living, whatever may be that. If that a collection is well defined, that collection is called a set. Okay now. So after learning the set, so we are going to learn how to represent a set. In mathematics, everything we will represent in notations to make the concept clear and simplify. So we will represent that concepts in notation form. So let us see the notation. So dear students, now we are going to see how to represent a set. Okay. So already we have explained that a set is a well-defined collection of objects. Okay now. So those objects we will put it in a flower bracket. For example, 1, 2, 3, 4, 5. This should be starting and this should be ending of the flower bracket, and each object should be separated with a comma. Each object should be separated with a comma. Okay. So these objects, whatever may be that may be living or not, may not be living, these objects are called the elements of the set. Elements of the set. This set is denoted with the capital letters. Capital A, capital B, capital C, capital C. This is the formation of the set. For example, B is equal to A, comma, E, comma, I, comma, U. Here the element should be represented with small case letters. If it is in an English language, if you want to represent, they should be in small case letters, and the set name of the set, whatever may be that, this should be represented with the capital letters. So this is the representation of the set and the notation, right? While representing and writing the set, you should be careful in some important thing. The first thing is every element should be separated by comma. That is the first one. Second one, while writing the elements in the set, you should be careful that there should not be any repetition should not be there. Sir, what is repetition, sir? For example, the set A is there. 1, 1, 2, 3, 4, 2. Yes, it is also a set. But you should be careful about the repetition of the numbers. Here, 1 is repeated 2 times. 2 is repeated 2 times. So, this also, of course, this also can be called it as a set. But while writing the set, you should be careful about 1, 2, 3, 4, that's all. Both sets are equal. Understand? So, one element should be written only one time. For suppose a set consisting of only one element S, that also should be written in a flower bracket, the number 5. Understand? Sir, if there is any set which does not contain any element S, sir, S, just to write down, just to 2 flower brackets. Don't write anything. Don't write anything in this. Afterwards, we call that what is the name of the set. Afterwards, I will explain. Understood? The first thing what you have to learn is the elements of the, so what are the objects in the set, they are called elements. The elements should be written in the simple smaller case letters. The sets should be denoted with the capital letters. And the third next one is, while writing the set, there should not be any repetition of the elements. Understand? Now let us see that some important sets in our mathematics what we are going to get. Okay now? Dear students, let us see some important sets which will come across in our throughout our mathematical study. So the first one is set of natural numbers. Natural numbers. The set of natural numbers is denoted with the letter N, capital N, and the objects are, you know, the elements are, you know, what are the least one? 1, 2, 3, 4, so on, infinity. So this is the way of representing the set of natural numbers. Okay. So the first least element is 1, the next element is 2, 3, 4. The greatest element we cannot say. That's why dot 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 we have to write down. Okay. So you should not write down up to show, don't close it, don't close it. So it is also a set of natural numbers, but it is a part of the set. So you have to write it as this dot dot dot. That means the set contains infinite number of elements. The last element you cannot say. Understand? So this is a set of natural numbers. So natural number set is also known as counting numbers. The set of counting numbers. Natural numbers or counting numbers. Why we call it as a counting numbers means whenever you want to count, you have to start with 1, 2, 3, 4, 5 like this. Okay now. So this is called set of natural numbers. So next set is whole numbers. Whole numbers. Okay, whole numbers. So what is the set of whole numbers is given by? So it is denoted by the letter W and it is given by 0, 1, 2, 3, so on infinity. That means set of natural numbers together with 0. Set of natural numbers together with 0 we call whole numbers. This is also sometimes we call it as set 0 union set of natural numbers. So I will explain what is union. This symbol is union symbol. I will explain what is that. That means natural numbers plus 0. Natural numbers plus 0. Union means just like plus. Natural numbers set of 0. Together we call it as whole numbers. Okay now, right. So next one is integers. Integers. Right. So this integer set is denoted by sometimes Z, sometimes I. Be careful, in some textbooks they will call it as X belongs to Z, or some they call it belongs to X belongs to I. Both are same. Z or I, both are same. So what are the integers? So this is a 0 to the right side, 1, 2, 3, so on infinity. To the left side, -1, -2, -3, so on infinity. So for natural numbers and whole numbers, we can say the least element, that is here 1 and here it is 0. We cannot say the greatest element. For integers, we cannot say the least element and we cannot say the greatest element. We cannot say. Both directions we cannot say, but at least here in natural numbers, whole numbers, we can say the least numbers. Okay now. So this is integers. Okay. So this is 0, 1, 2, 3, so on. This is -1, -2, -3. Again in these integers, there will be two parts. One is positive integers. Second one is negative integers. Let us see that. Coming back. So here what is meant by positive integers? So they are 1, 2, 3, 4. They are called set of positive integers. Right, set of positive. Have you seen this set anywhere? Anywhere? Just to observe, just to recall. If you recall, this is nothing but natural numbers. Nothing but natural numbers. So here onwards, whenever in the problem x is a positive integer, that is nothing but natural numbers. That means if you go on higher classes, there they will see that x is a positive integer. So don't worry, sir, what are these positive integers? Nothing but natural number. So natural numbers and positive integers both are same. So this set is denoted with Z plus or I plus or natural numbers. So these three notations are same. That is Z plus or I plus or N. So here onwards, whenever it comes set of positive integers, it is nothing but natural numbers. Okay na? So next one. The negative of these natural numbers, the negatives of this set of positive integers should all apply with the negative sign, that is equal to -1, -2, -3, -4, so on. So this is called set of negative integers. That is negatives of natural numbers. So this is called negative integers. This set is denoted with the symbol, this is a z minus or I minus, that's all, z minus or I minus. But there is one integer is there which is missed here. Observe here, anything which is missed here. 1, 2, 3, 4 came here, minus 1, minus 2, minus 3, minus 4 is came, but 1 is missed here. One element is missed, one number is missed, one person is missed. Who is that person? So that number is 0. That number is 0. What about that 0? Is it positive or negative or both positive, negative or neither positive nor negative or? So what is that about? There should be something, no? So 0 is neither positive nor negative. So there should not be any definition that you should not write down plus or minus. So if you are writing 5 means what? This is plus 5. If you are writing minus 5 means what? Negative of 5. But if you are writing plus or minus 5 means the x value takes, whatever may be that, x takes both plus and minus 5. But plus or minus 0 is meaningless. Plus or minus 0, plus or minus, if anybody wrote plus or minus 0 is meaningless. Understand? This is a wrong notation. So you have to write down, simplify anywhere if it is comes. So for example, x is equal to 0, that's all, x is equal to 0. Generally students, wherever if x is equal to 4 is there, therefore x is equal to, they wrote plus or minus 2. If x square is equal to 0, don't write down x is equal to plus or minus 0, don't write down. That is a wrong notation. If x square is equal to 0, it means that x is equal to 0, that's all. Of course, x is a real number, if it is a real number. Understand this? Okay. So after learning these positive integers and negative integers, there are some numbers which are not integers. Let us see that numbers. Okay. Now I am going to explain a set which is neither integers. Okay. Right. So what is the set means? Set of rational numbers. Set of rational numbers. As you know that the set of rational numbers is given by, we know the definition of rational numbers. Any number of the form p by q, any number of the form p by q, where p and q are integers and q is not equal to 0. This is called set of integer, rational numbers. The set of rational numbers is denoted by the letter q. For example, that means q means 1 by 2, 1 by 3, minus 1 by 2, minus 3 by 2, 5, 6, minus 3, 0. They are also rational numbers. Understand? Why? Sir, 6 is a rational number as 6 by 1. We can write down rational number. 5 is a rational number as 5 by 1. Sir, 1.5 is a rational number as 1.5 is equal to 15 by 10. We can write it as. So 1.34 bar, as it is a rational number as, we can write it as a rational number. There you, in the number theory, you will come across, these are all things are set of rational numbers. Okay now. So this is denoted with the q. Again in this set of positive rational number is denoted with the q plus, set of negative rational numbers is denoted with the symbol q minus. Here plus minus, that indicates that they are positive. This is positive, 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 positive. This is also positive. This is also positive. Negative means these are negative. As usual, 0 is neither positive nor negative. After learning these rational numbers, next we will go the total sets, natural numbers, whole numbers, rational numbers, and next thing is irrational numbers. After rational numbers, next we will see irrational number. Irrational number means what? The numbers which does not belongs to the set of rational numbers. They are called irrational numbers. Irrational numbers. So they are the numbers which does not belong to the rational numbers, which cannot be expressed in the form of p by q. For example, root 2, root 3, cube to root of 5, so on. They are all irrational numbers. So remember this here, a very, very important thing is pi and 22 by 7. What about pi and 22 by 7? So everybody says that, sir, pi means 22 by 7, therefore pi is a rational number. Of course, 22 by 7 is also a rational number. So always remember that pi is irrational number. Pi is irrational number. 22 by 7 is rational number. Understand? Right. So let us see the set of the whole sets. Whole sets, union of these sets, what we call it. Okay. Let us see this. Next we are going to see the set of real numbers. So set of real numbers. Yes. This is denoted by the symbol R. Set of real numbers means what? So this is a natural number set, whole number set, rational numbers and irrational numbers, everything. Rational numbers, irrational. So here plus means you use union. Union. I will tell what is this symbol, union symbol. That means the set of all natural numbers, whole numbers, rational numbers, irrational number together we call it as a set of real numbers. Okay, now here also we have the notation set of positive real numbers and this is set of negative real numbers. Okay, R plus R minus. Symbols means all real numbers will be there. 1, 2, root 2, 3 by 2, 22 by 7, so on. So these are all positive. That's why they are called positive real numbers. What is a negative real numbers? Minus 1 by 2, minus root 2, minus 3 root 2, so on, minus 1.5, so on. All these are all negative real numbers. Of course, 0 is neither positive real number nor negative real number. It is just a real number. That's all. It is just a real number. It does not belong to any one of the set. So on the whole, so real numbers means what? Set of positive numbers and set of negative numbers and set 0. Altogether, we call it a set of positive numbers, set of negative numbers and set of 0. These are all together we call a real number set. Okay, now after learning a very important sets we have learned. So what we have learned? So we learned about natural numbers, whole numbers, rational numbers, irrational numbers and set of real numbers. Next we have complex numbers. Okay, that also we have complex numbers. So just we are restricting our theory to the set of real numbers only. Okay, afterwards in another chapter I will explain about what is meant by complex numbers, imaginary numbers, that I will explain. Okay, now so next our concept is how to represent a set. How to represent a set. So we represent the set in two forms. One is a set builder form and the other one is roster form. Let us see that. So here we are going to see that representation of set. Representation of a set. So here set can be represented in two forms. One is roster form. This is also known as list form or tabular form. So second one is a set builder form. Set builder form. So this is very important, set builder form. Why? Because almost all JEE mains examinations or all over whatever may be that, if at all, if any set is given, if it is a finite set, okay, if it is an infinite set is given, that will be given in set builder form. Okay, you have to understand set builder form. What is roster form means, as whatever may be the elements present in a set, everything you have to write it in that set. That is called set builder form. That is how to list out. For example, if I say that set of first 5 whole numbers. Set of first 5 whole numbers means what? First of all, for that set you have to give one name. Let that name be A. You should start with a flower bracket. This call it as a flower bracket. Set of first 5 whole numbers. What are the first 5 whole numbers? 0, 1, 2, 3, 4. So these are the set of first 5 whole numbers. Understand? So here while writing the representing a set in set builder roster form, so as usual I told that previously I told, so every element should be separated by comma. There should not be any repetitions, that should be maintained. Understand? So this is the way of writing numbers in the roster form. But So there are some set which we cannot be represented in a roster form. For example, if I say that set of natural numbers, I say set of natural numbers, if I say that, I am not telling up to from where you have to start, where you have to end. So this type of some infinite set, generally infinite set, these can be represented in set builder form generally. Okay, now if there are so many elements are there in a set, for example 25, 30, if I say that the set of first 50 whole numbers, can you write the 50 whole numbers in a set? As we can write it, but if you represent this in a short form, okay, that will be very, very easy to understand. So that will be given in the set builder form. So in set builder form, how to write the set builder form means, first we will write the name of the set, whatever may be that, A, B, C, D, X, Y, Z, L, M, N, whatever may be that is equal to. We will represent the element in the set as a symbol, that is X. That is a X. X may be the number, X may be the person, X may be a living or non-living thing, whatever may be that. After this, we will write down two dots. That is called such that, we call it as such that. Sometimes some textbook you will write like this, slash, one slash. After that number or that slash or that dots, you have to write a common property of the elements X. Common property of the elements of the X. That means what? You will write out P of X. What is P of X? Is the common property. Common property of the elements of the set. Here also some P of X. What is the common property of that? For example, if you want to represent this set in set builder form, right? How to present? See here. First, I will write it as A is equal to, right, flower bracket. Here 0, 1, 2, 3, 4, so on is there. Let us call it, represent that number as a letter X, such that. What are 0, 1, 2, 3, 4? For basically, what are they? What are those numbers? They are whole numbers, such that X is a whole number. Yes, X is a whole number, comma. Is it enough? Is it that condition is satisfied? No. So whole numbers means what? There are infinite number of whole numbers are there. Okay. So how many whole numbers are there here? 0, 1, 2, 3, 4. That means X is less than or equal to 4. X is less than or equal to 4. That means the whole set 0, 1, 2, 3, 4. No, it is given by this set. So this representing this set in this form is called set builder form. Okay, now. So if I ask you to write down the set of first 50 whole numbers, set of 50 whole numbers means what you have to write down? 0, 1, 2, 3, 4, so on up to 49 you have to write down. But here X is such that X is a whole number and X is less than or equal to 50. If you write down 50, in this set there are 50 elements are there. Understand? So this is the way of writing set builder form. That means you have to represent the whole set, the elements of the set in a notation X, such that X is a whole number, real number, rational number. But what is a X? That you have to write down, and if at all any conditions are there on the X or Y, whatever may be that you have to write it. Okay, na? So I hope that you understand this representation of the set. Dear students, I hope that you understand today all the concepts what are the explained in the chapter set theory. Okay, there are so many concepts are there. Classification of sets, that is types of sets. One, what is empty set, what is a null set, what is the cardinality of this set, okay, and what is a proper subset, improper subset, number of proper subsets, number of improper subsets. So many concepts are there. We are going deep into the subject. Okay, na? So next class we will come with some more topics. Until then, goodbye.